Assalamualaikum and hi doctor. I hope you are doing well today. My name is AYAYSYAH binti HASNUL HANIZAMRI and my registration number is 2025127265. For this video presentation, I will be presenting two main parts, which is the introduction and how our proposed building design relates to the sustainable development goals. Before I start, may I ask you something? Have you ever thought how much energy our buildings actually use every day? Or how the design of one building can affect our climate in the long run? Actually, in Malaysia, the building sector uses about 40% of the country's total energy and is also a major cause of carbon emission. This mostly happens because of poor building design, bad material choices, and the lack of passive strategies like natural ventilation or lighting. We already have MICRES, which is a guideline for sustainable building, but sadly not many developers are using it yet. At the same time, Malaysia has committed to cut 45% of carbon emission by 2030 under the Paris Agreement. So the construction industry really needs to move toward greener and smarter solutions. For this project, our team was given a task to propose a sustainable building design for a government facility. We have selected 4 key innovations under material and technology (MT), all aligned with SDGs and MICRES guidelines. And to guide our ideas, we use the Cdio framework to make sure our design is not just creative, but practical and impactful for the future. Now let's look at how each building innovation supports specific SDGs. First, we have SDG 11. It's about creating more livable, resilient, and sustainable cities, which is green roof system, help absorb heat, manage rainwater, and reduce pollution, which directly supports this goal. Then we have SDG 6, which focuses on clean water and better sanitation. One way buildings can help is by collecting rainwater, by reducing dependence on treated water, and improving water use efficiency. Next, we also do SDG 7, promotes clean, affordable energy. By using solar panels in buildings means we can generate electricity from sunlight, reduce reliance on fossil fuels, and lower emissions, in line with this goal. Lastly, we have SDG 12, encourages responsible use of resources and reducing waste. Smart lighting helps building use energy only when needed, which saves power, reduce maintenance, and support a more efficient lifestyle. All 4 of these SDGs can be supported through building design. And this shows how sustainable building design isn't just about saving energy, but it's also how civil engineers contribute to real global goals. That's all from me on the introduction and SDG part. I will now hand it over to my teammate to continue with the MICRES evaluation. Thank you.
Hi, Assalamualaikum. My name is NURUL binti AZRIZI. My student ID is 2025513985. Today, I would like to brief share the 4 main sub-criteria under the Materials and Technology (MT) category. Based on the MICRES core criteria guideline, we have building orientation and passive design features. Second, we have sustainable and low impact building materials. The third one, we have energy efficiency and indoor environmental quality. Lastly, we have smart technologies for monitoring and control. These sub-criteria serve as a key framework to guide sustainable building practice through the use of better materials and technologies. Without further ado, let's move on to the next slide to explore these sub-criteria in more detail.
Assalamualaikum, my name is Siti ALEYANA. So now I will share the sub-criteria of material and technology from the MICRES core criteria guideline. The first is building orientation and passive design feature. A building orientation play a major role in its thermal performance and energy efficiency. For this project, the building is aligned along the east-west exit with its longer side facing north and south. This minimizes surface exposure to the intense morning and evening sun from the east and west. This orientation is ideal for Malaysia's tropical climate. It reduces solar heat gain, keep the building cooler, and lower layers on mechanical cooling system like air conditioner. Climate responsive design like this improve indoor thermal comfort while reducing energy use. It also support the UN Sustainable Development Goal, especially SDG 7, affordable and clean energy, and SDG 13, climate action by cutting electricity use and carbon emission. Orientation alone is not enough. Several other passive design strategies are also integrated. First is horizontal overhang on the north and south. Facade shades window from the high angle midday sun, reducing glare heat while letting in natural light. Second is double glazed window. Help insulate the building, reducing heat transfer and sound, which lower the need for air conditioning. Third, green roof on selected area, cool the building, absorb rainwater and support biodiversity, helping reduce the urban heat island effect. By using natural ventilation, combining cross and stripe ventilation to ensure continuous airflow without mechanical system, perfect for tropical climate. Material with high thermal mass, like exposed concrete, helps stabilize indoor temperature by absorbing heat during the day and releasing it at night. Lastly, clear story windows and light shelf improve daylighting, cutting down on artificial lighting and enhancing comfort and energy efficiency.
Hi and Assalamualaikum and good day everyone. My name is Zahirah binti AMIRUDDin and my matrix number is 2025513973. So for today, I will explain about the harvesting system as a part of sustainable and low impact building materials. In sustainable construction, a harvesting system refers to the technology used to collect, store, and reuse natural resources like rainwater or solar energy to reduce environmental impact. For example, is the rainwater harvesting system which captures rain from the rooftop or other surfaces and filters it for non-potable uses such as toilet flushing, landscape irrigation, and cleaning. This reduces reliance on treated municipal water, lowers operational costs, and helps manage stormwater runoff effectively. Harvesting system also aligned with the Sustainable Development Goal 6, which focus on clean water and sanitation by promoting water efficiency. By storing the rainwater for future use, it also helps conserve water, especially critical in regions facing water scarcity. This system often uses non-toxic, durable, and recyclable materials like food-grade tanks, UV-resistant piping, and locally sourced components to ensure safety and durability. Furthermore, harvesting system also support SDG 11, which focus on sustainable city and communities by encouraging green infrastructure and efficient water use. This minimizes stress on municipal infrastructure, reduce carbon emission, and increases water accessibility in health urban and rural area. For example, in Malaysia, in Putrajaya has integrated rainwater harvesting system to collect and reuse rainwater, various non-potable purposes. Lastly, under MICROS, it's implementing a harvesting system can earn 1 to 3 points under the ENW1 category, showing its impact in green building ratings. So that's all. Thank you.
So for this slide, I will be explaining the third sub-criteria under materials and technology, which is energy efficiency and indoor environmental quality. For energy efficiency, one effective way to improve energy efficiency is by using solar photovoltaic system. This system helps reduce our reliance on fossil fuel, which in turn contribute to lower carbon emission and reduce operation costs for building. It's a practical solution to achieve both environmental and economic benefits. For indoor environmental quality, this focus on using low VOC material. VOC are harmful chemicals that can be released from paint, adhesive, and other building materials. By reducing VOC, we can improve indoor air quality and reduce health risks such as respiratory problem, allergic, and discomfort among building occupants. These two strategies strongly support the United Nations Sustainable Development Goals (SDG), especially SDG 3 is good health and well-being, SDG 7 affordable and clean energy, SDG 12 responsible consumption and production, and SDG 30 climate action. For under the MICROS assessment system, using solar PV system can earn between 6 to 8 points under and 1.5. Using low VOC materials can earn 3 to 5 points under IEQ 2.1. So, in conclusion, by adopting these strategies, we not only promote sustainability but also improve occupant health and building performance.
Assalamualaikum and hi, my name is PUTERI RAIDATUL ZAHIDAH binti ZAMERI. My ID number is 2025195695 and I am excited to share with you my topic today, which is smart technologies for monitoring and control. So the example that I can give is smart lighting system, which is LED combined with motion sensor. So smart control and monitoring. So smart technologies allow remote control of lighting through mobile device or computers. It also giving users flexibility to manage energy use anytime, anywhere. So how it works? So motion sensors detect human presence and automatically turns light on or off. It also helping to prevent energy waste in empty areas such as corridors, washroom, and staircase. So what is benefits of LED? So LED lights consume 75 to 90 less electricity and lasts up to 25 times longer than traditional bulbs. It also reducing energy bills, heat production, and maintenance costs. So smart lighting systems can operate independently or be integrated into a building management system for centralized energy monitoring and control. Its also contribution to Sustainable Development Goals is short form to SDG. It supports SDG 7, that affordable and clean energy by promoting energy efficient technologies that reduce electricity usage. Secondly is SDG 12, is responsible consumption and production by reducing the demand of material and minimizing waste. And the lastly is SDG 13, is climate action by lowering electricity consumption, which help reduce carbon emission and support the global effort to combat climate change. So from a Malaysian green building perspective, smart lighting system support MICROS criteria, which is Malaysia fulfills. So MICROS requirements like MT01, sustainable materials that encourage the use of sustainable, durable materials like LED lighting, and MT03, energy saving technology that promotes technologies that reduce energy usage and environmental impact. So it's also helping to reduce operational carbon during building use. So lastly, for the conclusion, smart lighting systems are a practical solution for creating energy efficient, eco-friendly, and future-ready buildings.
In conclusion, and this project demonstrates that sustainable building design is not only achievable but also essential in addressing environmental challenges in leisure. By incorporating innovations such as rainwater harvesting, solar photovoltaic systems, smart lighting, and passive design strategies, we can significantly reduce energy consumption and carbon emission while also improving indoor comfort and the overall quality of life. These strategies also align with multiple sustainable development goals, particular SDG 6, 7, 11, 12, and 30, and comply with the standards set in the MOHD guideline. Ultimately, we believe this proposed design can serve as a practical model for developing more sustainable and resilient government building in the future. With that, we end our presentation. We hope this has given you a clear insight into the importance of sustainable building design. Thank you.